I was working with a student the other day on section 8.1, and we ran into something like this, where we are to convert these standard form equations into slope-intercept. Now, what strategy might you do for this? I would suggest you take your x term and bring that to the other side, where it will become a positive 4/3 x. So now you sort of have it in slope-intercept form. There's your y, x, and your constant. But plotting this would be rather difficult, so we need to get rid of the fractions. So what procedure might you use? Well, to get this to be just a plain y here, we go into our little toolkit and say we could multiply this term by the reciprocal of 3/4, which is 4/3. But if you multiply this term, you have to multiply this term as well, and this term. So I'm multiplying each term by the reciprocal of what is with the y. So now all of this will cancel out and just become a 1y. Now this one I'm going to multiply. I can't do any canceling. So this becomes 16/9 x. And here, can I cancel anything out? No. This is going to become plus 8/9. And that's what this person had. So they had this one correct. Now, once you fill this in, the graph forms. Now, we still have this other equation. And let's start to set this one up. Again, we want to put it in the slope-intercept form. Now, here our y value is negative. So I'm going to put that over to the other side here as a positive 3y. Just moving it from one side of the equation to the other. And then this becomes 6/5 x. And I bring over the positive 18. And on this side becomes a negative 18. Now, just to help out a little bit, we are used to seeing the 3y on this side, and then 6/5 x minus 18. I'm just writing it in a way that's more familiar. So now it's in this form. So, changing back to red, I want to get rid of these fractions. Now, I'm going to, in a sense, divide everything by 3. But another technique, remember this is 3/1. If I use the reciprocal of 3/1, I could multiply that by every term. So that's what I'm going to do. So this will be 1/3. Remember, dividing by 3 or multiplying by 1/3 is the same. But I have to do it to each term. So 1/3, 1/3. So again, here everything cancels out and I'm left with a y. Now here I can do some cross canceling. 3 will go into there once, 3 will go into there twice. So this now becomes 2/5 x. 3 will go into there once, 3 will go into there 6 times, and this becomes a negative 6. And that's what this person put in there. Now again, once you put these in slope-intercept form, the lines form. But now we have to state, is this consistent, inconsistent, or dependent, which we can't see, which is down below. And the answer looks like it has a point of intersection right there. So this would be consistent. And we go over, this is -5, come down, -8, which is what this person did and had it correct. In doing another example, just to get a little more practice, here is the original equation in standard form. Again, we want to put it in slope-intercept form. So I'm going to take my x term here and move it to the other side, where the sign changes from positive to negative, and the b term just stays there. So instead of moving my y and keeping the y's positive, we could leave it this way as well. We're still going to use the same technique, and I'll go to black. What is the reciprocal of a -5/9? Well, a -9/5, and that's a negative. So I have to multiply this term by, and I didn't leave enough room here, a -9/5, and this term by a -9/5. The key is whatever you multiply one term by, you must multiply all terms by to keep it in an equation. So we know then this is all going to cancel out. Negative times negative gives you a positive, and you end up now with a positive y, which is what you wanted. Now here we can do some cross-canceling. We know negative times negative will be a positive. This term is going to end up being a negative. So again, check your signs. Be careful about that. Now 5 goes into 5 once. 5 goes into 25 5 times. 3 goes into 9 3 times. And into 12 4 times. So now we have 15/4 x. Now here, the 5's will cancel out, and I'm left with a -9/3. Well, I could cancel out a 3 from there and a 3 from there. So this is going to leave me with a 3. Okay, so again, you go back, check your work, and catch things like this in a sense. So that's what this person put. And that's correct. So the line would form. Now, when you do this other equation, you're going to do it in a similar way. In fact, it's probably a little easier to do. When you finished, you realize it's the same equation. Now, by putting the same equation here and the same equation there, again, the same line is going to form. But the key is, what do you select? And I'm going to go all the way down. And here you're going to select dependent. Here, if you did this through another method, substitution or elimination, it would end up being let's see if I get my pen working. There we go. It would be like 0 equals 0. Anytime you end up with a true statement, that is dependent. If you ended up with a 0 equals 4, that's not true. These lines would have been parallel, and that would be inconsistent. Again, the graph shows really what you're going to get. That's the nice part of graphing. But again, these were a challenge. Okay, we'll wrap this up.